Hi, I'm Erik de Bruin. I'm one of the co-founders of Stekker.app, and I'll be talking about forecasting of energy prices. And why are we doing this? Well, we are trying to allow people to charge their electric vehicles on the cleanest and of most affordable electricity. And so, what's important to know about this is that, of course, all of the energy has to have a source. It has to be generated somewhere. And so, this can be solar panels, this can be wind energy, but it can also be fossil fuel. And so all of the energy has to be produced and consumed at the same time every second. So this is simply how the electricity grid works. It has to be in balance. So that also means that it matters a lot when you charge. And so this is the whole point of smart charging. So the cool thing about an electric vehicle, and I'll get into the forecasts in a second, but the cool thing about an electric vehicle is that it's basically available all of the time when you're not driving. So we may be driving too much anyway, but this is getting better with COVID, but it's very useful to have value from this car when it's not being driven. So it will have value when you're using it, but it also has value when you're not using it. So about 23 out of 24 hours, this vehicle is basically available for grid services. And so the other cool thing about it is that an electric vehicle can consume a lot of power, and it can also, if it's a vehicle to grid vehicle, if it's equipped with that technology, it can also supply a huge amount of power. So usually about 10 kilowatts. So it's a lot of power. And also it takes a lot of energy before it's completely full, and it will be able to supply quite a lot of energy before the range is completely depleted. So it's a very suitable candidate. And not just because of those energy properties, but also because it's a computer on wheels already, and it has its own internet connection. So very good situation. We can control the vehicle through the vendor API. So you have the automotive company, and they provide an API. We have currently an integration with Tesla, and we have an integration with Volkswagen right now, and we are adding integrations. Also, for all of the other vehicles, can be compatible with the smart charger, so we don't need to have a connection to the electric vehicle. We can also combine the two data streams, so we've put a lot of effort into being compatible with any kind of vehicle. And this all has to do with our mission. We want to allow as many people as possible to charge their vehicle efficiently, affordably, and basically make use of our resources in the best way possible. We also feel like the driver has to be in control all the time. So I'll demonstrate the app for now to show you that you are in control and how it works. So this is the Stekker app, and I have multiple vehicles here. This is possible to have one or more vehicles into your account. And currently I've set it up to charge, and I have another day to charge my vehicle. But let's say if I had less time. So for example, if I want to charge it tomorrow, it will create a different charging schedule. So it will charge, for example, in this green period all until 7 a.m. tomorrow, which is what I've configured it to do. But I can also simply go back and allow it to charge, for example, farther in the future. But the interesting thing is that the prices are not known for this point in time. So these dotted lines, they are basically our estimate. And this is what Tangent generates for us. So we basically use the API of Tangent to feed it all the data that is of predictive value, and basically get our prediction back. So this is all in production, and I'll talk about how we've done this. So very briefly about what we do. We are also optimizing, we're a team of 5 people, and we also optimize based on, for example, local solar production. So we can keep the energy that's produced locally, and only use it for charging the electric vehicles. But there are other kinds of schemes possible where you use smart charging. And we're doing this on behalf of utilities, car leasing companies, or automotive groups. And so there's also next development where we are charging stationary batteries. But we do feel that charging an existing battery that's already purchased for a different reason is the most efficient thing compared to, for example, adding batteries that are only useful for the grid. We don't need to use the resources if we already have batteries. So what we are trying to do in essence is to avoid charging when prices are high. We want to actually charge when they're low. So both make a lot of money. So to make a good charging schedule, you need a little bit of context. So you need to look far enough ahead to know if this is a cheap moment in time, or this is a cheap moment in time, or maybe it's farther down the road. So for example, in this case, over the weekend, you can charge on, for example, Friday evening, maybe even a Saturday, and if you're not going anywhere, you have until Sunday, and Sunday is probably the day with the best prices. So in this case, it's charging on Sunday. This is also when there are very often even negative prices. So it's pretty cool that you can actually earn money while you're sleeping, or earn when the wind is blowing and there's not a lot of electricity demand, or earn money during the peak of the sun. So at noon, basically there's a lot of solar being produced, for example, in the Netherlands or Germany. So many of these countries, they have more and more frequently, they will have negative prices. So this, of course, is very attractive. So how do we arrive at this prediction? Well, it all starts with data, of course. You have to have good source data. So for example, market data, or it can be, in our case, also solar data or weather data, holiday data, all these things you can use. So basically you build that into a single package, and it's being uploaded by the Python client that is provided by Tangent. So we built a Python stack based on Docker. I'll talk more about that later. And this it feeds it back into our system, and it's being used by the optimization engine, and that's being used to control the vehicle. And at the same time, of course, our user interface is also updated, and this data is also being used to show you what's going on. So the forecasting process itself, we basically have already an existing Ruby on Rails stack that we use to gather all of the relevant data. And then the forecasting system is a Dockerized system. It has access to the same database, and it can load all of these existing data. And it then prepares it into a data frame, calls the Tangent API, makes a prediction, and then downloads this prediction, and it can then insert it into our database again. Then the smartphone app, of course, will update the graph and start recalculating the charging schedule. And then the optimization engine will of course also start using it. Then there's the pipeline for basically deploying all of this. So we can continuously improve our system, for example, add other predictors that are of value, and improve that way. And we've started out with deploying immediately a process where we can do that in a very structural way. So we want it to be repeatable. We want to be able to roll back, for example, if we need to. And it has to work the same for the production and staging servers, all of these things. It needs to be automatically tested. That's basically, there are just criteria that we have. It feels to us like good hygiene. So how does that work? Well, when we merge code to our master branch, the code automatically becomes tested by through a GitHub action, which is basically just a couple of lines of code that run. And so it runs a shell script which runs all of the tests, and if these succeed, basically it will automatically build a new Docker image with all of the new source code in it, and that's uploaded to our container registry. And so whenever the production and staging servers are being, when the container is being run, they automatically pull the Docker image, and they run this new container with whenever the new input data appears. So for example, when the market closes, it will automatically use the new data and restart this process with the latest container image. So to conclude, we were very happy to be able to completely create an end-to-end working system within a matter of weeks that the users could actually benefit from. And we found it pretty straightforward to use the Tangent API. Whenever we basically bumped into something, we could basically call support, and we would be getting a very helpful call, and we would be on our way again. So we were very, very happy with that. And the initial prediction accuracy is already enough for what we are doing, but it can definitely also improve. So we're finding more and more ways to improve it. And that's the beauty, that we already have an end-to-end working system, and we now can iterate, and that's a process that we would love to go through, and with the goal, of course, with making this whole electricity grid more sustainable, making charging your EV and using your electric vehicle much more sustainable. So yeah, thank you for your attention, and have a really nice day. Bye bye.